Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook. Grab a pencil or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have some logarithmic exponential type problems. These are going to be quick skill recap for if you're taking the SAT, you might get a problem with exponentials or logarithms. You could get an exponential equation or a logarithmic equation. That is also a possibility. But I just want to go through some basic properties that will help you simplify your expressions and will usually make it easier for you to solve an equation. So give them a look. It should probably only take you, less than a minute for each of them. Give it your best shot. See if you remember the properties you need. And when you're ready, you can unpause the video. See how we did it here. So for the first problem, I'm going to start off by relabeling the base as a 2 because 4 is just 2 squared. So this is 2 squared to the power of log 2 square root 3. Now I'm not going to go into what log is all over again, but I do want to mention that it's helpful to have the same base on the log as we have on the ground. Now the properties of exponents say that I can simply multiply this 2 to the exponent on the outside, which is log 2 square root of 3. And here's where we really start to see some nice simplification, because there's a nice property which says a times log of k. Usually it's flipped around, to be honest. Usually it's something like k times log of a equals log of a raised to the k power. So this can kind of move up there. And that's exactly what we're going to do next. So in here, we can take a 2 and put that as the power here, which means we're squaring the square root of 3. And you can see why that's really nice, right? You square square root of 3, you just get 3. Now, the next nice property that we have is understanding that if we raise 2 to a power which has log base 2, those are going to cancel. So this is essentially 3. And the reason why it cancels is because if I remind you what the logarithm actually is, the logarithm is a specific value which turns the base of 2 into a 3. So when I raise 2 to that power, it's going to give me 3. Okay, now for this next one, let's take a look here. We have log base 9, and we're going to work with this expression. I want to rewrite this a lot nicer. Hopefully it has a 9 in it. How can I write that with a 9? Well, first let's look at the 81. It's not a very good color for this. The 81 is just 9 squared, but it's in a cube root. And if you remember, cube root is kind of like a 1/3 power. So this is 9 squared to the 1/3, or 9 to the 2/3. But also this entire expression is in the denominator. So I have to do something to the power because of that as well. This is basically 9 to the 2/3, but to the negative 1 power because it's in the denominator. Or in other words, 9 to the negative 2/3. Great. Now this expression, therefore, is the same as log base 9 of 9 to the negative 2/3 power. And we're going to reverse the rule that we just did, which is to take a number being multiplied and put it on the exponent. We're going to reverse that. We're going to take this exponent and put it on the front. So this is equals to negative 2/3 log base 9 of 9. That is a really nice expression to get, because in case you forgot, log of any base with itself is just a 1. So negative 2/3 times 1, well, that's just negative 2/3. Okay, some of these tricks of working with logarithms involve changing the base. And I want you to be comfortable with both that process and the process of using this power property, k log a equals log a to the k. All right, I think that's enough blab out of me. I'll see you guys next time.